Hello everyone. Let's solve today's LetCode question together. Okay, so the question is of medium level. Find single number 2. Let's read the question. Given an integer array norms where every element appears 3 times except for one which appears exactly once, find the single element and return it. You must implement a solution with a linear runtime complexity and use only constant extra space. Okay, fine. So it is pretty straightforward, right? So it is said that in this array, all the numbers, uh, so there will be all the numbers will repeat 3 times except one, and I need to find that element. So here that element is 3, and for this one, as we can see, 0 0 0 it is repeating 3 times, 1 1 1 it is repeating 3 times, but 99 it is a single time, so 99 is the answer. The constraints are norms.length each norms.length, so there will be at least one element, and norms I, so it means that the number can be negative, 0 or positive, and each element in norms appears exactly 3 times except for one element which appears once. Okay, got it. So yeah, so 0, and I know that. Okay, 0 has appeared 3 times. Nice. What I'm thinking is, so they are saying that the question is saying that all the numbers will appear 3 times, right? Okay, all the numbers will appear 3 times. How will I know? Suppose if this is 2 3 4 5 and 2 2 and then 1, then 3, then 4, so one number will only appear once. Nice. Okay, 4, suppose this is 2, and suppose there is 99, suppose there is 99 again, and then what should be another number? Then there is 1. Can there be a problem like 1 1 1 and then 2 2 2 and then 1 again? Because here 1 is appearing 3 times, 2 is appearing 3 times, and 1 is a number that is just appearing 1 time. So can there be a problem like this? Every element appears 3 times. I don't think so, right? Each element in norms appears exactly 3 times. So they are saying that it appears exactly 3 times. It means there will not be a good number like this. One will appear exactly 3 times, or sorry, either one will appear exactly 3 times or one will only appear 1 time. Okay, got it. So I'm thinking about a solution. So first let me create an example. So 0 0 0 1 1 1 2 3 4 5, here 0 is appearing 1 time, and then 1, so 0 has appeared again. 2 has appeared once. 3 also has appeared once. 4 also has appeared 1 time. 5 also has appeared just 1 time. So when I come at this point, all my possibilities are either 1 2 3 or 4, 1 2 3 4 or 5, right? So it can be any number. Okay, how will I know? Okay, 2 has appeared now. Suppose it is 6 7 8 9. Then when I reach at this point, I know that there are so many probabilities, right? The single element can be any one of these, the 2 3 4 5 6 7 8 or 9. So how will I know which of these is the probability? So 1 is only appearing once till now, so 99. Okay, so now till now the probability each these many elements, right? So any one of these elements can be a single element. So I will continue looking at this. So 2 is not it, so 2 is not a probable value, and 1 also, 1 is also already here. Okay, 3 is also here, so 3 also appears once, and 4 also has already appeared. 2 also has already appeared. Okay, 2, so 2 is not a probably. 99 is also not, because 19 also has appeared. Okay, so when I have reached up to this point, so 5, 6, 7 or 8 or 9 is the probability. But what I am thinking is, so if I use like something like this, then I will have to create an array of possibilities, right? So it will not be of extra constant extra space if I do this, because I will have to save all the possible elements. So yeah, that is the problem here. I can so this is one solution, right? I can just keep on uh, adding all the possible values to this array, and if I find that value, suppose if I find 5 again, then I could have removed 5. Now these are the possible elements, but this will not work um, because we only, the question is saying that uh, to use extra constant space, so I cannot use a, a data structure that is growing like this. mm, what I'm thinking is, this question is a bit different, because it is saying that all the elements exactly appear 3 times, and that element only appears one time. So maybe I can use this property, because this question could also be like, other elements are duplicates, other elements may appear anytime, and there is only one element that appears one time. This question could also be like this, but no, they say that exactly 3 times. Other elements appear exactly 3 times, and only one element appears once. So what I'm thinking is, can I do something like this? So number can be negative and 0 as well, right? Okay, I was thinking to make a product like 0 multiplied by 1 multiplied by 0 multiplied by something like that. But so suppose 2 2 3 2, then if I do 2 multiplied by 2 multiplied by 3 multiplied by 2, divide by 3, divide by what I was thinking is, so if this is the case, because it appears 3 times, so if I do a cube root of this one, then it will be 2 multiplied by I just want to utilize that property, exactly 3 times property. So if there is some element that has exactly appeared 3 times, I want to find the single element. How would I do that? X plus x plus x is 3x, right? 3x plus 3y plus z. How to find it? Okay, I'm not sure. Like even I cannot just do divide by 3 here. If I do divide by 3, then it will be x plus y plus z divided by 3, right? But I do not know. I do not know what is the value in this case. Even like I do not know the value of z. I think this is not a good idea. Let's see how would I do this, solve this question again. So there is 0 1 0 1 0, and the numbers can go up to 3 into 10 to the power 4, so it can go up to 2 to the power 31 minus 1. So 0 0 0 0 has appeared 3 times, 1 1 1 1 has appeared 3 times, 2 3 4 5 6 7 8 9. X Y Z and X Y Z and L. Then what will happen? X plus Y. Suppose there is minus y, because I know that that element must appear 3 times, right? So I will just do x minus x plus y, because I'm just assuming that this element will appear 3 times. Okay, then total sum, then it would be, okay, the first element would be x, and suppose if this element appears 2 times again, then it would be minus x plus y minus x minus y, sorry, x minus x minus x plus, sorry, minus y. Whenever I get any element, and then I'm doing minus x minus y. No, this will not work. So if this element will appear 2 times, then I just want to I want total sum to be just z only at last. Sorry, I want total sum will to be the value of this element only, value of the single element only. But how can I do that? X plus x y plus y plus y, z plus z plus z, L and E plus E plus E. X plus x minus, I'm not sure. This element appears 3 times, and only one element appears once. How can I utilize that property? All the elements appear 3 times, only one element appears once. All the element appears 3 times, Every element appears 3 times. All the element appears 3 times, only one element appears once. All the element appears 3 times, only one element appears once. If the element appears 3 times, then it will be 2x plus x minus 2x plus x. Then what will happen? It would be 1, 2, 3, 3x minus 2, 3 is 6x minus 4x. All the element appears 3 times, only one element appears once. I'm not sure how to use that property. All the element appears 3 times, only one element appears once. All the element appears 3 times, only one element appears once. All the element appears 3 times, only one element appears once. All the element appears 3 times, exactly 3 times. Only one element appears once. How will I know? 0, 0, 0, 1, 1, 1. If I'm looking at this, then okay, 0, 1, and then okay, I found 1 again. Okay, I found 2 again, 3 again. Like one way I need to do with linear runtime complexity, right? I cannot even sort these elements, because if I sort, then it will be n log n. So 1 can be that element, 2 can be that element, 3 can be that element, 4 can be that element, 5 can be that element, 6 can be that element, 9 can be that element, 99 can be that element, 2. Okay, now I know that 2 is not that element because there is a duplicate. I'm really not sure how to do this question, you know. I'm not clear. Is there a hint or something like that? I'm not really sure how to do this with using only extra space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 99. When I get to 99, so when I get to 99, you know, then there are so many possible values. I think that I should do some kind of mathematics, otherwise I will not be able to do it without using any space, because all these are possibilities, right? I'll need to check which element has appeared twice or thrice. So I think I need to use some kind of mathematics. I cannot store anything. So suppose I have raised here. I have raised at this element. Then The element can go up to 2 to the power 31 minus 1. And negative as well. 99 to how can I'm not sure. There is 3 into 1 plus 3 into 2 plus 3 into 3 plus 4. Then it will be 3 if I divide by 3, then it will be 1 plus 2 plus 3 plus 4 divided by 3. It will be 3, 4, 5, 6. It will be 6 plus 4 divided by 3. Four divided by 3 is 3 1s are 3. 3 3s are 9. 3 3s are 9. 1.33. So it will be 7.33. How can I do that? Like, I'll not be able to find that value. And another thing is that there is a duplicate XX, YY, Z. That solution. Subscribe to unlock. Oh no. Great. Bit manipulation. Okay, yeah, like I told, I need to do bit manipulation for this number. I'm not really good at bit manipulation. Here, how can I do bit manipulation? Uses extra space. Okay, this solution is not a good solution, and looks like my subscription has already gone. So bit manipulation. So they are using right shift, left shift, and things like that. Initialize two variables, 1s and 2s, to keep track of the count of each bit position. Tracks the bits that have appeared once, tracks the bits that have appeared twice. So funny. Okay. Trying to see the most quoted solution. Detail and explanation for single numbers. Okay. Given an integer array of integers, every element. Okay. Special case with 1-bit numbers. As others pointed, in order to apply the bitwise operations, we should rethink how integers are represented in computers by bits. to start, let's consider only one bit for now. Suppose we have array of 1-bit numbers which can be 0 or 1. We like to count the number of ones in the array such that whenever the counted number of 1 reaches a certain value, say k, the count reaches to 0 and starts over. In case you are curious, this k will be the same as the 1 in the problem statement. To keep track of how many ones we have counted so far, we need a counter. Suppose the counter has n bits in the binary form. There is an initial state of the counter which for simply is 0. For each input from an array with a 1, the counter should increase by 1. In order to cover k counts, we require if k is equal to 2 and p is equal to 1. If k is equal to 2, then m is equal to 1. We need only 32-bit integer as counter.
Hello everyone, let's talk about a new problem today. Array, you will see that there is only one element, that is 4. The output is going to be for this particular question. Right. Now here, let us look at every bit position. Here, you will see that every number that appears thrice will either contribute to 3.
First of all, for all norms, right, for constant n of norms, I'd want to for late sum position. Okay, sum is equal to the final binary sum like this. So this would yield to 1 2 3 4. This would yield to 4 1 2 3 and 1 2 3. So this would yield to 4 3 3. So that is what binary sum I mean. By binary sum I mean that. So first of all, I will change this into binary number. Const binary number is equal to and that, so this is a number and that to string. I want to change it to the base of 2. Okay, so this will change in binary. And I hope that it also works in on negative numbers as well. So what is negative of 2? If a is equal to negative of 2, then what is a dot to string of 2? Minus 1 0. Okay, but yeah, I think then that's the edge case there, right? So suppose if there is the number 1 0 and minus 1 0, then they are different numbers, isn't it? They are not the same number. I mean, there can be 3 2 and just 1 minus 1 0. So how can I consider for negative values as well? That is a question here. because there is negative values as well. Because if I am adding all this, then it will be just 1 1 1. There will be just 1 3 1 3 minus 1 2. So the answer will be 1 in this case, and in this case the answer would be 0. But we can see that this is a negative number. I mean, this is a 1 0 is a positive number, not negative number. But the answer would be -2, not 1, not so if I'm saying -2 -2 -2 and 2, then the answer would be 2. Yeah, answer would be 2. But if in case of the answer would be -2. Okay, so how can I consider that case as well, the negative case? Convert decimal to binary. So if it is -2, then it will be -1 0. How should I consider this case? Maybe I don't know, since it is negative, so there are 3 1s and 1 negatives. Maybe I can maybe I can sum, positive sum and negative sum both. So positive sum here is 1 2 3 3 0. Negative sum here is -1 0, right? And here I can see that, okay, positive sum is 3 0 and negative sum is -1 0. So if negative sum so if in negative sum it is still divisible by 3, I think that I will just know it from here, isn't it? If positive sum, it means that there should be 0, and Since this is also 0, so there is 0 0. It means that positive sum is fine. If there is negative sum, then it will be, since it is not divisible by 3, so this will be 1 and this will be 0. So I can see that it is minus 1 0. But in the case where positive and negative both are equal, then it would be 0 0. So answer would be 0 only. Okay, so it means that I'd consider both positive sum and negative sum. If I can get if positive sum results in 0, then look at negative sum. If both 0, if negative sum is 0 as well, then it means that the answer is 0, right? So first of all, I'm looking at positive sum because I want to see if there are any positive number that is a single number. If both is divisible for 5, then the answer is 0. So next, if I cannot find any positive number that is single, then I will try to find a negative sum that is 0. I mean negative sum. Then I will try to find a negative number that is single. Okay. Let's see. For constant n of norms, I will try to see let positive sum and let negative sum. So if n is less than 0, then it will be positive sum. If n is greater than 0, else it is positive sum. If n is greater than 0, then it is positive, right? So I will just add it to positive sum. Constant binary is equal to n dot to string 2, right? Base 2. So number, I also need to change this into number. So now since this is a positive sum, so positive sum plus is equal to binary. Otherwise, if n is greater than 0, then it would be negative sum. Negative sum plus is equal to binary, right? Negative, suppose if there is minus 1 0, minus 1 0, it will be minus 2 0. Okay, great. So this will give me positive sum and negative sum. Now I need to find what are you doing? Okay, sorry. So oh my god, I'm having a major headache here. My eyes are so paining. But okay, I'll continue. So I have got positive sum and negative sum. Now I just need to look at all the values for const. So this is my, but that will be my number, right? So a is equal to 2, b is equal to 3. What I did is c is equal to 0, c plus is equal to a dot to string a dot to string 2 0 1 0 9, and c plus is equal to b dot to string Oh no, actually it is C plus number 10 and 21, right? 10 and 1121. Now I need to look at all these numbers one by one. So I think that I need to convert it into string again. So C dot to string 21. Okay. I mean I need to convert it into constant constancy of positive sum dot to string. What I can do is I just want to get a number. Since it is 2 1, so what will be my value here in this case? It will be, since this is 2, it is not divisible by 1, it is not divisible by 3, so it will be 1, and since 1 is also not divisible by 3, so it will be 1. The answer will be 1 1. So find there will be a function find single element. So for 2 1 it will be 1 1, right? So constant binary. Okay. So yeah, this function will return that value, and now I need to convert that binary to decimal now. So zero zero zero, convert binary to decimal. Binary. So what I am doing is, if decimal, if it is equal to 0, then I need to do this again for negative sum. And then I need to convert this to binary again. And at last return decimal, whatever the value is. So first of all, let's try to write this function. This one, find single element. So first of all, I'll try to sum string is equal to sum dot to string, right? And then I need to go from constant character of sum string, I need to go character to character. So let us see if it is divisible by 3 or not, so if it is divisible by 3, then it will be 0. If it is not divisible by 3, then it will be 1. So if Actually, what I can do is sum dot how to change a string to uh, split. Three, then a dot split. Yeah, okay, that's fine. Sum string. So if ch if this number %3 is equal to 0, so if it is divisible by 3, then let I is equal to 0, I is less than sum string dot length I plus plus. If it is equal to 0, then I will just change this to but there will also be a negative minus value, isn't it? Suppose a is equal to -12, then it will be a dot to string dot split. There will be minus as well, so I need to consider for that one as well. If sum stri equals to negative, then continue. If it is negative, then continue, and if it is divisible by 3, then it will be equal to 0. Otherwise, if it is not divisible by 3, then it will be equal to 1. Okay, so that's it. And at last my value will be minus, since it is just 1, and this also 1, minus 1 1. So this will be my minus 1 1. This will be my string. And return some string. Okay, but this is not a binary value, this is just an array, so I need to change array to binary value, change array to number basically. So what I can do is return some string dot I think, what was the opposite of split? If a is equal to 1 2 3, then what will change it to string? A dot to string. What was it? Split splits the string to array. Oh, it joins. If I use join, a dot join, yeah, if I use join, then it would change me to string of. So how can I convert binary to decimal now? Binary to decimal. Oh my god, why is my laptop so slow? Okay. So I will add this, I will write this function again. So this will give me a negative sum value. And yeah. Actually this should be a array. It should not be a yeah, this would be an array. This would be an array, and find single element positive sum. Since this is an array, it is all the logic will be very different. It won't be that different though. So this would already be a sum str. Find single element. So this will be an array. Where did it go? I need to change my laptop. Okay, so this will be an array. New array, 32 bits, filled with 0. New array, 32 bits, filled with 0. So this will be a positive sum and this will be a negative sum. And add to sum, everything will be same. I don't even need to consider this right now. If decimal is equal to 0, then do this, return if decimal is equal to 0, then return negative of decimal. Negative, I can do that, right? If a is equal to 1 2, then a parse int a comma 2. Okay, if it is negative sum, then I need to place negative in front. So that's all I did. Now I need to do this add to sum function. I need to write add to sum function add to sum, there will be a sum and there will be a binary number. So what I should do is, and sum is a binary, sum will be 32 digit, binary number will be binary number will be a it will already be a number, so I don't even need to convert it into number. And binary number will be I'm just changing this into negative. I'm just changing this into positive. I can do that, right? If a is equal to 10, and I can do a dot to string to write -100. Suppose if a is equal to -10, then I could do okay, nice. So how can I add to sum? So there will be, suppose the sum is 0 0 0, I will have so many integer values, right? And binary will be, suppose binary will be equal to 1 2 3, then and binary is a number, it is not even a string. Anyway, what I should do is, I think that I should start from let I is equal to 32, because there are 32 digits, and for const do I need to change it into number? I don't even need to change it into number. And dot to string 2. So a is equal to, oh god, it's already taking such a long time. My laptop is so slow. A is equal to -10, then minus a dot to string 2. It will be 1010. It's funny, but I'm not sure. I'm changing a string to a string, and if I do minus, then it will convert to positive. Decimal. So what I mean is, so this binary it is a string, okay? Since it is a string, so I can just say character of binary. Oh, actually, no, I can start from the last one. Since this is 32 bits and binary, I can just actually count. I can just actually see where should I add. like it should be something like this, right? Sum I should be equal to sum I plus binary I. So I need to get I till here and do it until I is less than 32. Oh, I cannot do binary I though. This can only go to 0, 1, 2, 3. How can I add these two numbers? Um, I think I can start from the end. So binary dot length minus 1. So this will always start from the end, right? I will be at the end and j will also be at the end. Right? Because if the length is 3, then it will be 0, 1, 2. So what I can do is while j is greater than 0, I can just continue. Come on, laptop. I can just continue. So sum I will be equal to sum I plus binary j, and next time I will decrease I and I will also decrease I, decrease j and decrease I as well. I think this will give a better result. So yeah, and at last return sum do I even need to return sum? I don't think so, because I don't even need to return anything here, because JavaScript is passed by reference. So when I do this, then positive sum is already updated. Sum's value is updated. Output is 1, expected is -2. Why is output 1? New array size of 32. If array is of size 32, then suppose if array is of size 2, then it will be 0 and 1, right? So I think that it will always be, it will actually start from 1. So 210, 210 minus 210. Oh, if you see, then it is already, it is not adding properly. This would have been a number. So this is 2 and sum is 1 0. If it is 1 0, then it should have been here, right? 1 0. So add to sum and binary. I31 g is equal to binary dot length minus 1. Binary dot length minus 1 is equal to, length is 2, so it will be 1. Since j is greater than 0, j is greater than or equal to 0 actually. Okay, anyway, now it is 1. So this is 1 0 and another is also 1 0, so this is 2 0 now, and another one is minus 1 0. So why is this not? Add to some minus binary. Minus 2 minus 1 0. So it is 1 0, then why is not at, why is it? So when I'm passing 1 0, then it is adding. But when I'm passing okay. Expected is minus something something something, and 12 test cases have passed. But anyway, like the last mistake that I was doing was, so this parse int was changing. Oh no, not this one, but this one here, this binary. So whenever I do minus and string minus string of 10, then it will change into minus 10. It will change into integer. Yeah. So that's why it was not um it was not working here. Like maybe this is not sufficient. Suppose I'll just do it 34. If I do it 34, then this will be 33. Use test case. If I run, output is 5254524 I don't think there is 543217 here. Nan. Why is there so many nan? When do I get nans? Okay, here I can see that this string is too long, so that is why I'm getting nan here. Console.log n space binary. So this number, when I'm changing this, it is too long here. 2 to the power 31. Like how many bits? Isn't it like there are e plus 30? Let me see. If I convert this, then there will be too long. Too many characters for binary digit. What is happening? Okay. My laptop is too slow. I think that actually, we should use that bit shift and bit manipulation operators here. How many digits is here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 31 digits. It's not too much actually. This is 35, 30, 30 something digit. There is 31 digits only. So actually it should have worked, right? 30. I don't need that long of a, since I'm using 43, so I will use 32 here. I think I should stop my video here. So if I am looking at this one, then it will look at 0 first, then 0 should have been added, and then 1 should have been added here. Why is it nan? I don't understand that. Console.log z comma binary z. Why is some I is equal to some I plus number of binaries in nan? What is not a number? Because there is all 1 1 0 0 0 only. There are all ones and zeros only. Oh, okay. I think that when I'm changing this to negative now, it is changing into something else. So that is why I'm trying to just put it binary only. Binary got to string. So yeah, that is the problem actually. So when I'm trying to put this value to and when I'm trying to do minus this value, then it is changing into this string. So this is string, okay. Now I'm not even changing it into anything. Add to some negative some binary. I'm just like passing the string, but I do not want that negative value to come into play, because if there is negative minus 1 0, then there will be 0 0 1 2. I think that is fine, right? Even if it is 0 1 2, then that is fine. 0 1 2. So I will start from 2, and for if binary j, if it is equal to negative, then I will just continue. If binary j is not equal to negative, then I'm adding, otherwise I'm not adding, okay. And yeah, that's it. Yeah, I think this will work, but actually this is a really messy solution. Not so messy, but like the errors that I was getting, I could not tell that that would throw error. I was trying to change it into a positive number by using minus in front, then it was converting it into a different value. So yeah, like um, so what I was trying to say is, if this is a number 1 1 minus 1 1 1, and suppose if this is a number 1 0, and if I'm trying, if I convert this into a binary using dot to string, then it would convert into 1010, right? So this is a string, and if I am using minus in front of a string, then it was not changing, then it was not converting it into positive number properly. It would convert it into 1010 for small digits, but for longer digits it would just do 10 e to the power 1 2 3 something kind of thing. So yeah, we need to so yeah, I think just converting string into integer using this minus, that is something we need to be careful about. Okay, so this was my code. Yeah, thank you for watching.